Okie dokie. So now we're going to do, we're going to graph two inequalities, and when we're doing a solution, where were we on the thing? When we have two inequalities, it's like having a solution to a system of inequalities. Okay? And like when we had a solution to our systems of equations, we get an ordered pair for the answer, right? Okay, for an inequality, we're going to get an area, a shaded region kind of thing. All right? So, let's graph our inequalities. So I'm going to have y is less than or equal to negative x plus 2. And so when I get my handy dandy protractor ruler, okay, and it's a solid line because it's less than or equal to. And if it's less than or equal to, which direction do I shade? Above or below? What do you remember? It's less than. What if you can't remember? How do you check to see? Pick a point. Let's pick a point as 0, 0. Is 0 less than 2? Yes, so that's in the shaded area. And yes, less than's below. Oops. Greater than is above. All right, now let's do our second one. So I got y is greater than or equal to negative 2x plus 4. And then go down to 1, 2, 1, 2, 1. And my line looks like this. And this is greater than, so it's going to be above the line. Okay? So our solution is the area where I have both shaded. I got to hit both of them. Okay? Good so far? Should we do one more? Oh, sure, why not? What the hey? I love graphing. All right, so negative x plus 6. Now, if I'm dividing by a negative 2, there you go. Therein was my reminder why I wanted to do it. If you divide or multiply by a negative sign, then you flip the sign. So I'm going to have y is greater than or equal to 1/2 x minus 3.
So, every single product you divide.
No, the rule is if you multiply or divide by a negative sign, just in general, then you flip the sign.
What are you multiplying or dividing?
I divided on this one because I had negative 2y. And I wanted to get y by itself. So I divided everything by a negative 2. And since it's greater than or equal to, I'm shading all of this area above. And so to put my next one in slope-intercept form, I'm going to have 3y greater than or equal to negative 2x plus 0.
What points are you plotting?
my y-intercept, the b, so I did -3, and then I went up 1 and over 2 to the next point with my slope.
So you did your
Yeah, so like on this one, my y-intercept is 0. So I start at 0, and I have a -2/3 slope. So from that point, I'm going to go down 2 and over 3, and that gives me the next point, and I can draw my line. And this is a greater than, and again, my solution set is going to be just the area where I have both cracks hitting. Good so far? Okay, I've got some vocab for you. So, a graph is considered bounded if the graph can be contained within some circle. Okay, so, and it's unbounded if the graph cannot be contained with some circle. Okay, so basically what that's saying is that if I took my graph here and I drew a circle, okay, my graph is still extending out on this one. I can't put it into a circle because these lines are going on infinitely, so my solution set's going to be infinite. Okay, does that make sense? So many times we end up with, in order to be bounded, vertices or corner points, which are really your points of intersection of the boundary lines. Which will make a little bit more sense once we graph these, okay? All right, so my first one, I have x is greater than 0, okay? If x is equal to 0, that's basically my x-axis, right? So, and it's greater than. So I'm going to highlight all of that. And then if y is greater than 0 or y equals 0, that's like my y-axis. And since it's greater than, it's everything greater than there. Good so far? Okay, now, flashback for you. What quadrant of the graph is my solution set in right now if I had just those two equations? 3, B, 1, Nicole, which one? 1, because it starts in the left corner where everything is positive, and then it goes counterclockwise because it's the shape of the circle. It follows the unit circle. Okay, so now let's graph this line, and so that's going to be y is less than or equal to -2x plus 6 over 1. And so that means right now I have everything in that area. And then finally, my last line, 2y less than or equal to x plus 6. So y is 1/2 x plus 3. And so my line's here, and it's less than, so that means my area is solution set is here. And that's what it means to have, these are my vertices, which are my corner points, and this is a bounded graph because I can make a circle and the entire graph is definitely contained within the circle. There's nothing going on forever later on. Oh, yeah. It should have been. But, so it's just going to go the other way. It's going to go the other way, but it's still, yeah. That was more about a demonstration on the boundary. But yes, you're good. Okay? Does that make sense? Yes, sir.
How do we know how wide the circle's going to be?
Doesn't matter.
Doesn't matter.
Circle doesn't matter. You don't ever want to say it has an infinite radius, because then it's not really giving you anything, because everything could be infinite. But when it's bounded, it's usually so that it's contained, and you can see the whole graph. You know, like I can't see the whole graph on this one up here because it's going on for infinite. But I can see everything here. I can see exactly what my solution set's going to be. That's what it's more about, what's bounded. Does that make sense?
Yeah.
All right, let's skip the next one and do a word problem. Okey-dokey. Okay, so we have a retired couple. They can invest up to $25,000. Okay, as their financial advisor, we recommend that they place at least $15,000 in treasury bills and at most $5,000 in corporate bonds. So what we're looking for is to write a system of equations. We want X to denote the amount of money invested in the treasury and Y for the amount in bonds, okay? So X is going to be our treasury and Y is going to be our bonds, okay? So first thing I need to do is I need to think about what we know. I know I can invest up to $25,000, all right? So that means X plus Y is going to equal 25. Would you agree with that? Yes? Okay, because whatever arrangement I have, I'm going to invest up to 25,000. All right. It's recommended they place at least 15,000 in treasury bills. So that means X has to be greater than or equal to 15. Okay. And at most 5,000. So that means I want Y to be less than or equal to 5. Do you agree with that? Okay. So my graph doesn't fit these numbers. So I'm going to say that for every third line, I'm going to make that a 5. So for 3, so really my unit of measurement's going to be like a 1.2 or something like that. So 1, 2, 3, I put 5. 4, 5, 6, I'm going to put a 10. 7, 8, 9 is going to be 15. 10, 11, 12 is going to be 20, and that's going to put 25 up top. And that's okay to do that. Okay? All right, so now let's graph. So my first graph of x plus y equals 25 is going to be y is equal to negative x plus 25. So my starting point is going to be at 25. And I'm going to go down 1. Good. Okay, my second line, x has to be greater than 15. Oh, I forgot to change my y, sorry, on there. So, 1, 2, 3 is 5, 4, 5, 6 is 10, 7, 8, 9 is 15. So if x is greater than or equal to 15, that's going to be right here. So right now, oh, I think I did something backwards. Bonds was treasury. Okay, let's keep going. Y is less than 5. Oh, no, I'm good. Y is less than 5. So that means this little section right here, where all three of them hit, is the points of where they're going to make the most revenue based on what they pick. So like if they picked, let's say this number here would be like 16,000 and then 2,000 in, what was the Y? Your bonds, that's when you're going to make the most money. Does that make sense? That's the purpose of system of inequalities are used a lot for business and like breakthrough as far as break evens. If here's the cost, I need to charge from this range to this range to make the most amount of money kind of thing. Okay, good? Yes?